Thanks, everybody. So I'm Mike. I work for GridGain. We are the commercial enterprise that originally contributed, excuse me, Apache Ignite to the Apache Software Foundation. So a quick agenda. I'm going to talk a bit about GridGain and Ignite and how those two entities work together. We'll talk a bit about the Ignite in-memory fabric. Then we'll talk about Ignite and compare it a bit with Spark, and then talk about how Hadoop and Spark can integrate with Ignite. So a bit about the Apache Ignite project. 2007 was the first version of GridGain, and we went all the way through a 7-year period until October 2014, when we contributed all of the source code to the Software Federation. And then we went through an incubation period that ended up with us being the second fastest after Spark project to graduate and become a top-level project. And it's a very big community. There are well over 80 contributors now, and as you can see, these stats come from OpenHub, 230 plus years of effort, and a very mature and sizable code base, and I would say a very tight code base as well. So one slide only about GridGain. So we provide the enterprise and professional editions of Ignite. The professional edition is really just a wrapper around the open source version, which gives you access to our support and access to our developers. The enterprise edition comes with some more enterprise-level features, data center replication, and some additional security features, and some local reload stuff that we'll talk about a little bit. One other thing to say is that all of the contributions that we make to the code base end up in Ignite. The earliest bug fixes do go into the professional and enterprise versions. So a few use cases. I've only actually really joined GridGain very recently. I come from the financial sector, where I built a number of systems based on distributed data caches and compute technologies. And we have a lot of use cases in automated trading systems and financial services, risk analysis. But it's not just that area that our technology is relevant. Online and mobile advertising and big data analytics, obviously, very key part of what we're talking about here. And one new area that we're moving into is travel and e-commerce. Some very interesting applications there for real-time booking and real-time pricing. So what is an IMDF? So I toyed with the idea of breaking this out into the words, but I'm trying to create a new 4-letter acronym. But it's an in-memory data fabric. So all of the pieces of that puzzle that you can see in the image there are different aspects of what Ignite can do for you. So the top left, we have the data grid, and we have the compute grid, which gives you distributed computations across your whole cluster. We have the service grid. So I don't know how many of you attended the round table, but the idea of large clusters of microservices, you can deploy those straight into an Ignite cluster and start benefiting from that type of architecture immediately. The streaming aspect, we can stream in data and perform complex event processing type workflows across it. That is really powerful. Once you combine that with the data grid and possibly with the compute grid, you get this really incredibly integrated, powerful suite of applications. So this is really breaking that out. Can you see it? You can see it. Good. One other thing to mention is the distributed data structures. So it's quite interesting that we have distributed queues, atomic variables, and other widely distributed, thread-safe data structures that you can build into your applications and which give you the ability to synchronize and distribute information widely across your cluster. One thing I want to talk about. So the clustering is really interesting. cluster, what's the word I'm looking for? Discovery. So discovering new nodes in the cluster is done typically in a normal Ignite via multicast, but you can also deploy an Ignite cluster into, say, AWS, where multicast is disabled. So the interesting thing about the clustering is that all of that discovery is completely pluggable. So for AWS, we came up with a new version of the discovery, which is based on a piece of shared S3 storage. And if you have a private cloud that has similar issues where you can't or don't want to enable multicast, then you're able to write something custom that still allows your nodes to discover each other and join and leave the cluster. So I want to talk at quite an abstract, high level, very briefly about an in-memory computing platform. So the central, if I can point, so this central slice here. If you think about your platform as being composed of a compute grid, a data grid, and then possibly some external persistence layer if you need to store your information further out. And we'll talk and look a bit at the compute grid and the data grid. So data grid is distributed hash map, you know, the classic kind of architecture that's been around since I started working with this kind of stuff, best part of 10 years ago. And also an in-memory database. So we have full SQL 99 compatibility, so you can run full SQL queries across your cluster of data, and then a full compute grid. So you can run distributed closures across your whole grid. You can integrate those distributed closures with what's stored in the data grid, and combine those two to create something really quite powerful. So kind of going back a little bit to clustering, I guess. So how do we do horizontal scaling, and how do we do fault tolerance? So an Ignite cluster has, well, an Ignite cache, in fact, not a cluster, has the ability to run in two separate modes. So the first mode is a replicated cache. So this is a cache where you've got multiple copies of the data stored in multiple nodes in your cluster. Advantage of that, you blow away a node, you still have your cluster. You blow away, you know, as many nodes up until a limit, you still have your data. In that replicated cache, you can also have a near cache. So if your client is separated by the network and has a set of hot data that it knows it needs, or that it can, you know, figure out that it needs, then it can store that data much closer to itself, eliminating network traffic. The partitioned cache is an alternative way of looking at this, where the data, instead of being replicated on all of the nodes, is partitioned into separate sectors, and you can co-locate relevant data together via something called the Affinity key. So if you know that a piece of data A will always be required with a piece of data B, then you can create an Affinity key out of those two pieces of data, and they will always be stored together in the partition cache. In that partition cache, it's not just one copy of each piece of data. You can have backups, and you can specify how many backups you need. So you can get a mixture of the safety of the replicated cache with extra performance and functionality from the partition cache. So having talked about vertical scale, let's talk about, having talked about horizontal scale, let's talk about vertical scale. So the interesting thing about Ignite is, first of all, off-heap memory. So we no longer are required to store data in the JVM heap. So that's kind of, you know, pretty powerful. You're moving outside of the garbage collection world. You are able to take up all of the memory space on your servers and on your nodes and fill those with data. But we don't just stop there. When it really gets interesting is our tiered memory model. So Apache Ignite has 3 tiers of memory. We can have on-heap, so, you know, coming back away from that off-heap model. You can store in your heap up until a limit. And then once that limit is reached, data will be spilled into the off heap, and you can still access that completely natively. There's one extra pointer dereference, I believe. So there's a very small amount of overhead. But then if you've managed to fill, let's say you have a, 64 gigabyte machine or something, if you manage to fill that with data, you can then spill that into local swap. Now, again, at the round table, the idea of making your local swap on your node SSD gives you access to vast amounts of storage on a single node. I found that really interesting. Recovery is kind of the opposite of this. What happens if this server blows itself up? So for that, this is actually an enterprise feature. There's the local restartable store. So instead of having to go back to your data source, whether that be a relational database or across the network, you can restart from a local store that's on each node and contains the data for that node and gives you much quicker recovery. So storage and caching with Ignite. So let's look at that data grid. So the in-memory data grid is 100% JCache compliant. JSR 107, let me go to my notes. So the basic cache operations via concurrent map APIs. We've got co-located processing via JSR 107, events and metrics, and pluggable persistence. So the Ignite data grid, as I mentioned previously, distributed key value store, SQL queries. So every person I speak to who's like, oh yeah, it's a key value store. I've seen those for best part of a decade now. And then you tell them that you can take your existing SQL queries, put that data into an Ignite cluster, and run those SQL queries without modifying them. Even an Oracle DBA who I spoke to about that last week, I think it was quietly impressed. We've got ACID transactions and in-memory indexes. So even if you need to store your full data either off-heap or further out into swap, you can keep the indexes to that data in either on or off-heap memory, and you can perform very fast searches of that data and then retrieve the results. And finally, the data grid acts as read-through and write-through to, say, a relational database, a NoSQL store, or a Hadoop cluster. So distributed computing. So there's really two ways, and this is kind of abstract. And if we have two scenarios, essentially. If we have a large amount of data, then we can either go and select that data out of the data grid, take it to some processing node, perform our calculations, and then return the results out. But, as I'm sure many people here know, the cost of doing that probably vastly outweighs the cost of sending the computation to the data. So that's something that can be done by combining the compute grid with the data grid and the affinity keys. You take your distributed closure, put it out to your cache, all of it runs locally with the data, results come back, and then you pass them back out. So that compute grid, it's got a direct API for MapReduce. It's got load balancing and automatic failover, and a cron-based task scheduler. So if you need to have tasks and computations that run periodically, instead of having to build that yourself, that's built into Ignite. That phrase built into Ignite is something that if you download and experiment with the product, you'll be saying to yourself over and over again, oh, that's built into Ignite. There is a vast amount of functionality built in. It's right down at the bottom, but arguably it should be at the top or maybe in a bigger font. Zero deployment. So there's no requirement to deploy onto your nodes the classes for what you want to run. So you can add a new node into the cluster, and that node does not have to have been pre-configured with the up-to-date class files because we have a distributed class loader. That distributed class loader is pulling up those classes on your node. Once the node joins, it pushes the classes on there. It loads them up, performs the calculations, and then, very key here, flushes those out of memory again. And that flushing allows you to, whilst your cluster is running, release updated versions of those classes and distribute them out to your grid without having to take anything down, restart anything. You can run your grid for as long as you dare, essentially, and update it on the fly. Check how I'm doing for time. Okay, not too bad. So Hadoop and Spark integration. So I will admit that I am something of a neophyte when it comes to Spark. I started with it, a couple of weeks ago, and grasped the concepts, and then was very quickly able to integrate it with Ignite, which I found really quite interesting and rather exciting. So just some comparisons between the two. I'm sure that everything on the right-hand side are things that you would agree with Spark to a greater or lesser extent. It's very strong machine learning libraries and a huge community. But it is based around RDD and Dataframes. And I think it's changing, but my interpretation is that it still certainly leans towards the disk rather than memory. Whereas Ignite is very much an in-memory product. As I've mentioned, we do spill to disk, but that's really an unusual scenario. So instead of having to come from IGFS or a distributed file system, Ignite can take its data from anywhere. So I've taken it from Oracle databases, and I've taken it from flat files, and I've taken it from SQLite databases, all sorts of stuff. As I mentioned before, the SQL support and off-heap memory and all of those good things. Okay, so Spark and Ignite, it's really a drop-in integration. So there are two key classes, Ignite Context, and that's the main entry point for Spark Ignite integration. And what you do is you create your Spark context, and you pass that to the Ignite context, and then those two are meshed together. And then we have an Ignite implementation of a Spark RDD. And what's interesting about that is that we've got three modes of execution with that. The first one is where the RDD is stored within the Spark job. So the Spark job starts, it has the Ignite RDD, it uses the data, and then both of them go away and die at the same time. That's like an embedded mode. There's a second embedded mode where the RDD is part of the Spark worker, so it's part of that worker's process, but it's not actually dependent on the job. So the job goes away, but the RDD carries on living. I would say that the third mode of execution is probably the most interesting, or offers the most alternative ways of viewing things. Instead of the data just being dependent on a Spark worker, instead it lives completely outside in its own Ignite cluster, but it's completely integrated with Spark via the Ignite context and the Ignite RDD. And the data can live on through the whole application of a Spark grid. You can take the whole Spark cluster down and bring it back up, and your data in your Ignite RDDs will still be present. And that means that you've got a controllable lifetime. So as I mentioned, you can share data across jobs on the host, across jobs in the application, and share data globally. And you can even make that data, should you want to, and this may be slightly controversial, it can actually be mutable data. So instead of being an immutable RDD, it can actually be mutable. Now, for those of you who are using Spark SQL, again, you can benefit from the built-in SQL with Ignite. So you can get the power of in-memory indexes, and you can run SQL in memory on those shared Ignite RDDs. just a bit of code here. It's really those 6, 7 lines that allow you to go from knowing nothing about Spark, as I did, to having a working Spark application. Now, one of my colleagues was asked about Dataframes, since it's another way of working with data in Spark. And it turns out that it's perfectly fine to use Dataframes with IgniteRDD. There's the code there. All of this code, by the way, is on GitHub. There's a link at the end, or come see me, and I'll get you details, and I can provide you with a link. One final thing to mention is the IGFS. So we have an implementation of the file system, but completely based on Ignite and completely in memory. So it's Hadoop compliant, it's on and off heap, and it can act as a caching layer for HDFS and write through and read through on that underlying HDFS. And that should give you a fairly significant performance boost. So the final thing I think this is that Spark plus Ignite. If you're using Hadoop, then we also have a Hadoop accelerator. So it's giving you many of the same benefits that you get with the Spark integration, but it's plugging directly into your Hadoop. That one is slightly different. There's actually a specific build of Ignite that you integrate into your Hadoop ecosystem. A few words to say on deployment. So you can deploy locally, obviously. We have it working in Docker. You can get it on AWS, Google Cloud. We've got it on the Azure Marketplace, Mesos, Yarn, Carafe. Pretty much there's an integration for any open source platform that you can think of. There's one for Ignite. And that's it. Thank you very much.